Okay, guys, so we're going to get into talking about parallelograms. Parallelograms is a certain kind of polygon, or you can think of it as a certain kind of shape. And parallelograms have certain properties. So that means they have certain rules that they follow. So we're going to learn a little bit about parallelograms, and then we're going to answer questions and solve problems based on the rules of those parallelograms. So, first, let's talk about the definition of a parallelogram. The definition says that a parallelogram is a quadrilateral. And we know that a quadrilateral means that it's got four sides, right? Um, and it's a quadrilateral where both pairs of opposite sides are parallel. So that just means that both sides or both pairs of sides just never cross each other. Okay, so other important rules are that opposite sides are congruent. Congruent, we know, means the same. So I'm going to put opposite sides congruent. So opposite sides are going to be exactly the same as each other. Okay, opposite angles, congruent. So not only are sides that across each other exactly the same, angles that are across each other are exactly the same also. Okay, second or third rule, consecutive angles, and that means angles that are on the same side. Okay, and we'll look at that in a minute. They're not congruent, they're supplementary. And you should know, we should remember together that supplementary means that it equals 180 degrees. Okay, and then the last rule is that the diagonals bisect each other. Okay, you should be thinking in your head that when I say bisect, that means that it cuts them in half. So the diagonals cut each other in half. And we'll see what that looks like in just a minute. Okay, so let's do some problems together. Oh, don't want to do that. Okay, here we go. So let's look at number 1. So the very first question that they're asking me in number 1 is what's AD? Okay, AD is right here. I know opposite sides are congruent. So if I want to know AD, all I gotta do is look over here at BC, and it's telling me BC is 8. So AD must be 8 also. Okay, it's asking for DC. DC is right here. So if opposite sides are equal, all I got to do is look at its opposite side, and they tell me it's 15. So I know DC is also going to be 15. Pretty easy, right? All right, next thing it asks for is angle A. Okay, so if I want to know angle A, I don't have its opposite angle. If I did, that would make it easy because they're supposed to be equal. But I do have this angle right here that's right beside it. Those are called consecutive angles, and they're supposed to equal 180. So if I do 180 minus 68, I'll get 112. So that means angle A is 112 degrees. Okay, then it asks for angle B. Okay, that's easy because opposite angles are congruent. So if this angle is 68, that means that this angle is going to be 68. Okay, and then the last one is angle C. If I look at its opposite angle, it tells me it's 112. So angle C will also be 112 degrees. Okay, so pretty good, huh? Let's skip on down to number 13. So number 13, first thing they want to know is UT. UT, which is right here. I can look at its opposite side and see that it's 27. So that means that UT should be 27 also. Okay? ST, here's ST. Look at its opposite side. See that it's 18. Oh, wait, I want to do that in green. Hold on. There we go. See, it's 18, so ST is also going to be 18. Okay, VS. VS. Here's VS. I'm going to just kind of put it in purple so we can really see VS. Now, what we know about the diagonals, and that's these little crosses right here, they bisect each other. That means they cut each other in half. So that means that this, I'm going to do it in yellow, that means that this little yellow line right here cuts this purple line in half. Well, I have that this side is 7. So if that yellow line cut it in half, then this VS side is also 7. So VS, I'm going to put 7. This side 7, that side 7. Okay, then it asks for VT. Let's do VT in orange. So this part is VT. And then they give us this little piece of information down here where they say RT is 30. So RT is going to be 30. So the whole thing is 30. And we already found out that that's cutting it in half. So half of 30 is going to be 15. So that VT part, the part that they want, is just going to be half of the whole thing, which is 15. Okay? So sometimes they're just going to ask for, like, you to give them straight up measurements like that, just regular numbers. But you know that sometimes they're going to want to throw a little X in there. Okay? So we're going to look at how to solve some equations involving parallelograms. So look at number 7. So they want us to solve for x. Now we know if they want us to solve for x, I need to set up some kind of equation. And I need to use what I know about parallelograms to set up this equation. Okay? So right off the bat, I see that they have given us opposite sides. Okay, I have this expression and this expression, which are opposite sides. We know that opposite sides are supposed to be equal to each other. So I can just set those two expressions equal to each other and then solve it like an equation. So I'm going to have 9x minus 25 equals 5x plus 7. Okay, I need to get all the variables on one side, all the numbers on one side. So I'm going to minus 5x. And then I'm going to move this 25 over, so plus 25 plus 25. So then 9x minus 5x is 4x equals 7 plus 27 is going to be 32. Divide by 4, divide by 4. So my x is actually going to equal 8. So that's all there is to it. So look at number 8. Number 8 are also opposite sides. So I would just take this 11x plus 1 is equal to this 19x minus 31, and I would solve the equation out till I got what x equaled. Okay? Let's look at a different kind of problem. So let's look at number 9. So they're telling me right off the bat that TV is 74. So that means that from here, from here all the way to here, it's going to be 74. And I'm just going to write that down so I've got it. And then they tell me WV, which is from here to here, is 4x plus 1. So I've got to use what I know about parallelograms to set up an equation to solve for x. So I know that this little side from W to V and this side from T to W are equal to each other, right? So if this side is 4x plus 1, this side is also 4x plus 1. And both of those added together are supposed to equal 74. So if I want to set up an equation that looks like that, I'm just going to write the first one, which is 4x plus 1. and I'm going to add it to this second half, which is also 4x plus 1. And the whole thing is supposed to equal 74. So then I combine like terms and solve. I have 4x plus 4x, which is 8x. 1 plus 1, which is 2, equals 74. Minus 2, minus 2. So I have 8x equals 72 divided by 8 divided by 8. X is going to equal 9. Okay, let's look at number 10. So number 10, let's just label what they've told us. NS is 2x plus 7. So N to S is 2x plus 7. SQ is 5x minus 23. And then it wants me not to find x, but it wants me to find NQ. Okay? To find the actual measure of NQ, we know we do this all the time. I've got to figure out what x is, and then I can plug it in to find out what the whole thing is, right? Okay? So to find x, I've got to set up some kind of equation based on what I know about these two parts. Well, you should know that those two parts are equal to each other, right? Because the diagonals bisect each other, it cut it in half. So I know that this green part is equal to this maroon part. So I'm going to set up the equation where it says 2x plus 7, which is this part right here, is equal to 5x minus 23. I'm going to subtract 5x, subtract 5x. I'm going to subtract 7, subtract 7. So that's going to cross out. That will cross out. So I'm going to have negative 3x. Oh, that didn't cross out. Oh, hold on. I've done messed up. No big deal. This crossed out. Okay. So I'm going to have negative 3x equals negative 30. Divided by negative 3, divided by negative 3. X is going to equal positive 10. Okay, but that's not what they wanted to know. They wanted to know what NQ was, which is from, let's get another color, which is from here to here. Okay, so I'm going to plug in x right here and see what this part is. So x is 10. So 2 times 10 plus 7. 2 times 10 is 20. 20 plus 7 is 27. So that means this part right here is 27. Now we know if this part's 27, this part's also going to be 27. 27 plus 27 is 54. So that means NQ equals 54.